Welcome back to another little adventure. Welcome back to a little adventure. This time we'll be going over Gray Hat Python. We'll be going through the whole chapter just step by step. If you have any questions on anything, feel free to drop it down in the chat. Welcome to ask any questions. I'm learning for the most part too, but just so we can learn together. I'm going to go through this whole thing. So from C types, C types is a foreign function library for Python. It provides C compatible data types and allows calling functions in DLL or shared libraries. You can use to wrap these libraries in pure Python. It allows it to have a deeper understanding of it all. So then we're going to assign these, how they assign them in the book. So for the most part, I'm going to be spitballing at a lot of this, but it's what it sounds like. So the C.use short is a string that's short, and that's what it is in C. I will look that up right now. Use short looks like it's smaller than the amount of bytes, a certain amount, and then there's U long as well. Alright, and then from there, we're going to create a keyword. And then have that long. And so that's over a certain amount that the string can have. And then OB byte. Five, six, seven. Looks like it wants to start the debug process first and then run the new console second. And then from here, so we're creating a class, startup info, having the structure in there. And then within this array, we're going to define all of the different variables. The top is LPT str long pointer string, and then this is long pointer byte. Don't forget to add the comma at the end of all of it. There's going to be a lot of these for this because we're creating our own debugger, creating all the definitions throughout it all. I'm not the most literate when it comes to debugging, so for the most part I'm just going to be following along. I know that a lot of these are just defining the variables for our future programs. That's all I really understand. So the standard input is what you put in, standard output's what comes out, and then any error handling is the standard error. This shows the window and able to show what we want. This is the flags and able to pick up different things. Flags are typically what you put in if you were to do echo-n and then put words in Linux programming, and then you would be able to get whatever words you got out of there. Fill the attribute. I don't know. There's a x and y variable. I think x and y is just the first and the second. You're going to be multiplying each one, shows the size of each one. X and y, those are the actual numbers that count the characters. So it's count characters, it would be counting how many are within each one. The title is the title of everything. Desktop is desktop. Reserved, I do not know CB. Then that will be that whole class, and then we're going to create another class. Then again with the structure inside of it, put the fields, and then put it within an array. And this one won't be as large as the last. Only 4. They all have nope, they don't have all have handle. And these two have D word. And that should be everything for right now for the debugger defines.py. And then we're going to move on to the my debugger. So then Control S to save your program, and then the next one. And then if you're in Visual Studio Code, that's the IDE that I'm using, more like a text editor, and able to get into the Zen mode, you do Control K at the same time and then press Z, and then that'll bring you to this. And then from there we're going to import C types, import everything, and then from my debugger defines, import everything. So everything we just created, now we're pulling that in and able to use that with the debugger. Kernel 32. I don't really understand too much of what that's doing. It's just assigning the kernel to be what the Windows DLL is. I think it's just initializing the program for the most part. And then we're putting itself within it, so we know how to initialize, and then we're passing. Creating another function within it. We're defining it, a self path to exe. So the DW creation flag determines how to create the process. The set the creation flag equal to create new console if you want to see the calculator GUI. So creation. So that debug underscore process actually came from the my debugger defines what we just created in the last script. Instant initiate the structs. I don't know if that's a word, but that's what they use in the book. And startup info. And that's having startup start the startup. Actually, we want this in lowercase, so what they have. Now it has commented the following two options allow the startup process to be shown as a separate window. This also illustrates how different settings in the startup structure can affect the debuggy. Now it has commented, we then initiate the CB variable in the startup structure, which is just the size of the structure itself. Yep, so size of grabs the size and then, yep, initializes it. If everything goes as planned, then it'll show that everything has launched successfully. And PID is a process identifier is what PID is. Process identifier processes run throughout the machine. That's what calculator is. That's what this program is. And then we're going to show to you, the user, what it is. And then we're done with that for right now. Save it. And I'll exit out. And then I'm gonna create my test. And then within this, we're gonna do import debugger. And that starts the program, and that's what debugger is. And then we're gonna call the next one, saying debugger.load. And then this is gonna be within Windows. Alright, and save, and then it says that once you save on Windows, so launch the process, and the process number 1856. That's pretty cool. That's awesome. So now that we got it started and everything is running correctly, I'm just going to keep on going throughout the book, and whatever it says I'm going to add on. This will be quite a while because right now I'm only on page 29 of the whole chapter, and chapter goes all the way out to page 57. right now I'm reading it. It's a little bit confusing because how he has it, it makes it difficult if I'm supposed to add it or if he's teaching about how to add it and then if he adds it later. What it looks like is he adds it later and he's teaching the portions that I'm reading about right now. So I'm gonna go back now, going back to my debugger, and then so after initiate, then it's self.h process so again initializing the variables. Alright, so then go down to load, path to exe. And then what it says below this is obtain a valid handle to the newly created process and store it for future access. Self.h process equals self.open process information DW process ID. And then now we have a whole new function to define. It's going to be attached. So attached to that process. Make it better for all of you to read. And then self dot I did not do the one that was above that because we definitely needed to open the process before we can do that. So then self and then so once it opens, it initializes all the variables within it, the process all access, the PID and the false, and then returns the process for it. So then we're able to actually open it up. Next, it's defining the attach. From there, self.h process. So what we just opened. Next, it has commented that we attempt to attach the process. If this fails, we exit the call. And then with that, and able to pull up the find, it's Control F. And then looking for the debug active, because it was somewhere else. Oh, it's in the other program. And then I think when you ran the Python program, it gives the PyC. I've never really seen that before. That's cool. So then looking for this again, the debug active process was in the test. We are just creating it now, and it's something that's actually branched off of kernel 32, so it's actually something that the program already has within it, and we just have to correctly label it, otherwise it won't call it, and it'll either give us an error or do nothing because of it. And then we're setting the state of the debugger to true, which means it would be on, and then the PID equals an integer. Integers are numbers. And then self.run. Starting the program. Ready to go. Otherwise, we print that we can't do it. Then from there, it says now we have a pull to debuggy for the debugging event. While loop keeps on going until everything within it is accomplished. Right now I'm on page 32, and so it'll keep on running through until it gets the event and runs everything. And then our next definition that we're going to do, function, we aren't going to build any event handlers just yet. Let's just resume the process for now. So it has commented within it, and then from there press the key to continue. False. We're going to have the first parameter within it debug event. It even says right there the PID is process ID. That's awesome. And then DW thread ID. So that's the amount of threads. That's the amount of times we can run it. So it's like if you had a sports team, a thread would be one person, and then if you had 2 threads, it would be 2 people on a team, and the amount of threads is the amount of different processes that can be running at the exact same time, doing the same thing if you want that to be done. And then continue. Status. And then the final one right now is detach. Again, initializing itself, able to know what to call. And it'll error out the program if this is code. Save it. Go back to my test. And then since we just added all of that, that means we're now able to input, which is awesome. So you can pick which one you want. So then once that's started, we have the user input it, and then from there it'll be whatever number is the PID, process ID. And then once it's done, it'll detach. And then to test this out, the following steps: choose start, run all programs, or you can just go in here, calculator. Right click the Windows toolbar and select Task Manager. From the pop-up menu, and then press the Process tab. Alright. And then if you don't see a PID column in the display, choose View Select Columns. Oh, here we are. Perfect. And then go to the calculator, if we can even find it. ensure the process is checked, and click OK. It says view select columns. I don't have a select columns on here. And then ensure the PID checkbox is checked and click OK. Find the PID that calc is associated with. Well, there it is, and then that's the number. Execute the test with the PID found in the previous step. Okay, perfect. 15008. So then control and then the backtick, and then Python. Says it's invalid syntax. And that's within my debugger. I think this is supposed to be an equal. Alright. And then we're gonna write invalid syntax again. Line 64. Supposed to be a comma. It says that it's correct syntax within the book. Oh, I see what I did wrong. I incorrectly didn't do the equals. Alright, there we go. Haha. And there's the number. Has no attribute to attach. It says that it cannot attach. Well, that would mean within the debugger that we didn't put attaches right here. So attach didn't work. It says self.open, and then we have within it if kernel active process. And that is on the same line. Debugger equals true, that, and then run it. And then we didn't even get this because it should either do this or this. And if neither of those ran, then it came and find attach. I'm slightly confused to why that is. Well, that's a funny thing. Probably should type that in correctly. I wonder if each process debugger active, and then it passes. Actually, I don't even know if it's supposed to pass anymore. It's supposed to pass before. Yeah, it's supposed to pass before, but we weren't supposed to keep that with it. So still, it has nothing to attach to. I don't know what I'm doing wrong. Okay. From there, I really don't know what to say. I'm lost, to say the least. I'm gonna go off of someone else's GitHub that they have able to go through all of it, able to actually understand what's going on with the whole thing with the debugger. The book makes it way too complex with jumping around and adding in values everywhere, and I don't really know where I'm going wrong with it all. So with this, I'm just going to code in the whole thing of my debugger along with the define. If the define has anything else, I don't know if it does. It has a lot more. And then along with that, going to add in the test. The test doesn't have so much more, so we'll just do that first. So then from here, we'll have the printf equals bugger. And that's everything that we have for this program. And then we're going to go into my debugger, which this is going to be a long time to go through all of this. Alright, so, yep, C types, import all, debugger, yep. We also want import the system and import the time. Still have the debugger. They space that. If they space that, I'm guessing that's to make it look better, which it does. Breakpoints within that. It's a lot more that we're adding. So this is a breakpoint, is being able to go into the program, which is what all debuggers do, and they're able to stop the program wherever the first stop that they want it to stop at. And then they also add the system info. So that sets the page size, which then is created from the system info DW page size. Alright. And then we define the load. And then this, whoever this is, copied everything, even the comments from the book. Being creation flag, yep. Startup info process, yep. So we're setting the state of the debugger to true, which means it's on. And then we're printing the error. Getting the last error. Alright, from here, starting the open process. And it's the exact same that we have right here. It says this is an undefined variable. Even with how they had it, it still says it's undefined. Alright. And then we have I'd rather space this apart, it just look better. And then return we have the attach. If kernel is active, then we set it to true. We set PID, and then they don't even have self.run here because it's its own thing. And then print unable attached process, define run self. And it doesn't even have get, says debug event equals debug event. And then continue status if kernel 32 dot wait for debug event, and then it has a time of that's 1/10 of a second. wow, we have a lot to add, change around right here. I'm just gonna erase that for now. Self.h thread. The percentage %d means that it's going to be a digit. And another digit. And then the percentage allows these next two that are going to be within here to then be allocated in the order that they're designed. So then the DW debug event code is going to be the first one, and then the DW thread ID will be the second. And then we're having the exception address equals the debug event.u exception record. And then within that it says call the internal handler for the exception event that just occurred, and then if exception is equal to exception then we will print that there's an access violation. I love how Python has else if elif rather than else if in JavaScript. It's so much shorter and nicer to type in. Little things. And then if the exception underscore breakpoint, then we'll continue the status to self dot exception handler breakpoint, and that's the breakpoint we'd want. Otherwise, I'm gonna quick try to find out what DW means. So W is a word, DW is a D word, which means a 4-byte integer. W means a 2-byte short integer. P is untyped point. LP is a generic long pointer. LPSZ is a long pointer to a null determinate string. Someone posted that 14 years ago. Thank you. Appreciate that. That's awesome. All right. That link, I'll put that if anybody else wants to see that right there. It's at the very bottom. Again, thank you for watching. I appreciate it. It's awesome just being able to go through all these step by step. I'm not trying to speed teach or be the best teacher in the world. I'm trying to understand it on my own right here, and some of this is really difficult for me to understand, but it's fun going through this and just being able to have other people that can relate and understand the same way. It's awesome. Debug event.dw process ID continue the status, and that's everything for this portion. So then that's what we want there. Alright, I lost my place. And then, oh, we were right there at the kernel 32. Ah, I see. Okay. And then, whoa, we have a lot more to include along with that. So now that is the exact same, we want it to be true or false and then give the error. But I do not know. Love typos. Alright, and then now we're going to go down the list of creating everything else. Creating the open thread. This allows us to have multiple processes going at the same time. If the thread is not none, then return h thread to them. So whatever they put in, then that's what it'll be. Otherwise, else. Print and we'll return false. That is something I was curious about. I almost think that it couldn't see the attach just because it's not in the correct line. Ha 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 ha. That's probably why it didn't work earlier. Oh, this is fun. Had everything on the wrong one. I just realized as I was looking through the other code. Probably, I don't know what would be an easier way to do this. Okay, just highlight, yeah, highlight it all and delete it all. Perfect. All right, and now done with the open thread, and then enumerate the threads, which means count in a more sophisticated fashion, because, you know, programming industry has to sound intellectual. I mean, if it was so easy that everyone could do it, then there'd be no reason for me even doing it right now, right? So then the thread entry is the thread entry 32, which then takes that from the kernel 32. Thread list is then an array list, and the snapshot is kernel 32 create the tool help 32 th32cs snap thread. We have some crazy things going on that I have no clue, but it seems awesome. Eventually, I will learn all of this. Just right now, it's as I go. snapshot is not none. Where is that again? Alright, then thread entry dev size, thread entry, yes. And then that, yes. Okay. And then below that we'll have a while loop. So while it's successful, then we'll be going if thread entry.t process id equal to self.pid. Then we'll have the thread list dot append thread entry.th32 thread id. And then we're defining success. And this will make sure that nothing is leaked. And then from there, we'll return the thread list to the user. Otherwise, else, turn false. Next one, we'll define as get thread context. Would it be better for the look of it to have a space here or not? I've always had it without a space. I don't know which one would be better. If you want to comment on that, that'd be greatly appreciated. Space here, make it look better. And we're gonna have context, so then we can have it here. And if the H thread is none, then set it to self.open thread, and then have the thread ID. Yeah, this would be hilarious. I was just thinking to debug this whole thing. Debug a debugger. Oh, that's hilarious. because I'm writing so much, which is very improper to do. Because what you should do is test it throughout the whole thing. I just don't understand how to go throughout the process of doing this if I don't even understand where to start from. It's quite a big problem to do and able to chunk it up, and I don't even understand how it quite works. But for the most part, whenever you're writing a program, you want to be able to take a chunk, test it, take a chunk, test it, take a chunk, and test it. And that'll have the buffer length, and then where it'll start counting at to read the memory. Initializing the data, the read the buffer, and the count. So having the data be the raw input from the read buffer, and then we will return the data. The next function we will create will be the write the program, write the process memory, and like always we have the self, then the address, and the data. Self will always be in there because it wants to be able to know its count itself. And don't forget the semicolon. That's not a semicolon. I forget what it's called. Colon. Yes, and then you don't forget to add the colon to the end of the function, able to add and include what is inside of it. I do that quite often right now because I get so caught up on myself. Write the process memory, and then C that belong. Of the value, and this will have the first value, and the colon after it means it'll take all the values up until it, and then it won't take anything after. That's when it's in an array block. So what it'll do is it'll search for the C character inside of data, and then take it. Oh, whoa, that's cool. Oh, that's neat. I didn't know there was a thing, so you can go like this and then put it somewhere else. Oh, cool. And then it'll take the count value, and only the count value and nothing after. But it'll take everything before, so if there's anything else before, it'll take that as well. That's what the colon means inside of an array bracket. And what you typically want to do when you're programming is the first thing that will typically be the error, you want that to be first. So on this one they said if not kernel 32 write process memory, then they wanted that to be first because it'll fail out. Instead of if it were to return true, then it could fail out but still return true because of that. So you have to be cognizant of what actually is more likely to happen and what is the problem, and then you add that as first, and then whatever you want. What you want to happen is usually always last, because you want all the errors to be ran through first before your program finally goes through at the very end. And then we'll be printing to the user the setting the breakpoint. For you, and then putting in the address for that breakpoint. So it'll have this part before it. We'll have, I think what will happen is that this is saying 08x. I think that 08x is the start. It means a byte, so then it'll add the address into where this is, this whole part, and then it'll have the 0x before it. I think that's Intel syntax is how that is. And then from here, that'll go inside of that, and then it'll set the breakpoint and show them what the breakpoint, show you what the breakpoint is. That was not intended. I spelled that incorrectly somewhere. Aha. There, I spelled it incorrectly. Alright. So it goes through that, the virtual protect, EX, and then it sets the process, the address, the value of 1. So this was at the very beginning when it was the my debugger presents, my debugger defines. And with that, this is all the values that will go within that. And then from there, my thoughts on this now is to slow down on this book. Actually, I'll push this book back. It was going to be my top priority to do this, but I figured that it'd be more beneficial for me to actually be able to instruct and help and guide everyone on what I'm actually doing. I don't even know what I'm doing for the most part right here, so it's a little difficult. But I want to be able to finish this whole thing, and then once I'm done with all of chapter 3, I'll stop and wait on chapter 4 until I do a lot more code wars. And then once I actually have a lot more code wars with Python underneath my belt, I'll actually understand this a lot better, and then I can come back to this and teach you all this a lot faster and better, which that's what everyone wants, right? Everyone just wants everything to be super fast. That's all society is super fast. Alright, and then from here, we'll go back to this one, else, it's actually not this one, it's the earlier one, and then return false. We're about 3/4 of the way through this one, there's a lot to go on. Again, including self into the function, and then printing what we wanted to print. Print an exception address at the byte, and then include the self exception address inside the byte. Check if the thing is, I don't like comments in my code, because if you're not able to have someone read it and they're not able to understand it by reading it, then comment is a last resort. I completely understand that there's a time and place for comments, but having too many of them unnecessarily makes no sense, because you should just have your code logic make more sense to the user. That's the whole thing with all of coding and programming, is the only reason we code and program is to understand from other coders and programmers, and that's all it is. It's not to have a computer understand it the best, or else everything would be written in machine code, so only machines can write it, and we wouldn't even need any humans to even program. And so then print the exception address, and this is going to be the exception, if not self breakpoint, and then put the key in for the exception address. And then this will look for the first breakpoint that we're allowed to go into. If it is a first Windows driven breakpoint, then let's just continue on. Yep. And so then it'll say true, otherwise it'll say false, and then print, it'll hit the first breakpoint, and then it'll go back up to here. Assign that as the breakpoint, and then it'll print that address. So it'll just keep on going through this. This could have been a while loop. I don't understand why it's not, but then it just returns that. Okay, and then from there, otherwise, we print hit user defined breakpoint. This is where we handle the breakpoint we set, which we first original. Okay, and so then this will write to that breakpoint and set those variables inside of it. Get the thread context. So this will be the amount of threads that we want to have. And then set the thread context, yep. And then continue status, and then continue. Alright. And then we'll include that which then it's the function resolver has itself, the DLL. I'll look up what DLL is right now. I've been wondering that for a while, especially since I started diving into Windows. DLL, what is DLL? An article describes what a dynamic link library is in various issues that may occur when the DLL. There are various describes some advanced issues that you should consider when you develop your own DLLs. It describes what a dynamic link library is. This is an article that describes dynamic linking method, DLL dependencies, DLL entry points, exporting DLL functions, and DLL troubleshooting tools. Okay, interesting. If anybody wants to read more up on that, I'm going to be reading on that after this. But there it is. And then I'm getting annoyed with not understanding and not being able to teach well on any of this. So what I'm going to do, I'm actually going to be done with all of this, the whole book and everything. If you want someone that actually can program it and they're literate on it, they're literate enough and able to provide the code for it. I'll link their and there's that. That's everything that they have for all of this book. I'm gonna wait for this now and be done for right now. I'm actually gonna start Code Wars because that's gonna be a lot more beneficial for your learning, and I'm gonna be able to actually help you with that. So thank you so much for watching. I appreciate it. I hope that you learned some things with this, and if you have any feedback, I definitely would love to hear it down below. Thank you. Hope you have a great day.